This next lesson is on sum and difference identities. Again, these are identities, but we will not be using these very often, if at all, in proving identities. More likely, these are going to be used in solving trig problems. For example, you know things like sine of pi by 4. You know this is root 2 over 2. Okay? But you don't know something like sine of pi over, let's say, 5. Okay? Or say sine of pi over 12, because those are not exact values. So questions like this, we're going to be using some of these identities that are shown on this page. Okay, they're all on your formula sheets. You don't need to memorize them. I would get used to having your formula sheet beside you while you're doing these questions, because you should be periodically checking to see which identity to use. Okay, so let's spend a little time getting comfortable with them. There are 6 here. There are addition identities for sine, cos, and tan, and also subtraction identities for sine, cos, and tan. Okay, so let's take a look at this one. It says write the expression in simplest form. So you would look at this and you'd go, okay, simplest form. Do I know what sine of 8x is? No, I don't. I don't know what cos of 3x is. So you should say to yourself, let me look at my formula sheet and see if there's any formula that looks like this. Sine alpha cos beta minus cos, now look at 8x is the first angle, so alpha, and then this would be sine of beta, that would be the second angle. Okay, let's see if this is anywhere over here. So we're looking for sine cos minus cos sine. And if you look up here, I see right here sine cos minus cos sine. So that means this is equal to sine of alpha minus beta. So let's go up here and put those values in. So what was alpha? Alpha was 8x. And what was beta? Beta is 3x. So this simplified would be sine of 5x. Okay? So these two are equivalent using the formula that we're given here. Okay, so look at the next one. In this case, if you think of cos alpha cos beta minus sine alpha sine beta, is that one of the formulas? So we're looking for cos cos minus sine sine. Well, that's this formula. So I can write this as cos alpha plus beta. All right? See, that's cos alpha plus beta. So what is alpha and what is beta here? Alpha is 33 and beta is 27. So this is cos of 60, and cos of 60, you know, is half. Okay, so that's one way the question could show up. I think I might have a multiple choice question on the test for you like that. But more likely it's going to be like this, where we're going to have to use the formula to evaluate this, because sine 105 is not an angle that we know. This is not an exact value, and the question is asking for an exact value. So this is not where you pull out your calculator. You're supposed to find the exact value of sine 105. Now if it was sine of 45, sure, I would know how to do that. If it was sine of 135, sure, I would know how to do that. But I don't know 105. So what I'm going to do is, instead of writing 105, I'm going to write 105 as two angles that add up to 105. And they have to be exact values. So my exact values are 0, 30, 45, 60, 90, etc. Do any of these two add up to 105? Well, you can see that 45 plus 60 would work. Okay? Would it be okay to, say, put 30 and 75? Well, 75 is not an exact value, so that's not going to work. They have to be exact values. So I'm using 45 and 60 degrees. So I've split it up like that, and I have a formula for sine alpha plus beta. Okay? So here's what I'm thinking. I'm thinking sine alpha plus beta, and I know that formula is sine alpha cos beta plus cos alpha sine beta. So let's put this into this formula. So I would have sine 45 cos 60 plus cos 45 sine of 60. Okay? And each of these is an exact value that I can figure out. I know that sine of 45 is root 2 over 2. I know cos of 60 is a half. I know cos 45 is root 2 over 2. And I know sine of 60 is root 3 over 2. So this is going to be root 2 over 4 plus root 6 over 4. And they should always have common denominators for you already. You don't need to simplify. You can just put it together like that. Okay, let's try the next one. So this one's a lot harder, because we're good with the degrees, but we're not so good with radians. Okay, what I want to do is write this as a combination of two angles that I know, but I don't know any pi by 12s. So here's what I'm going to do. I know I have pi by 6, pi by 4, pi by 3, pi by 2, and then the next one would be 2 pi by 3, and the next one would be 3 pi by 4. Let's put those ones into pi by 12s. So this would be 2 pi by 12. This would be 3 pi by 12. This would be 4 pi by 12. This one would be, where am I here? Pi by 2, that's 6 pi by 12. And then 2 pi by 3, this is going to be 8 pi by 12. And this one is going to be 9 pi by 12. So do any of these add up to 11 pi by 12? Well, I have a couple of choices there. I could choose 9 pi by 12 plus 2 pi by 12, or I could pick 8 pi by 12 plus 3 pi by 12. They would both work. Okay, now I'm going to change these back to what they actually are. This is 3 pi by 4, and this is pi by 6. So I'm going to look for the cosine addition formula. All right, cosine addition formula is cos alpha cos beta minus sine alpha sine beta. So each one of these you should be able to evaluate now, because they're all exact values. Okay, this one's negative root 2 over 2. This one's root 3 over 2. This one's root 2 over 2. And this is a half. So I get negative root 6 over 4 minus root 2 over 4. And I can write that as negative root 6 minus root 2 over 4. Okay, pretty tricky questions. These questions are all the same. We have 6 different formulas, so we could be using any one of those 6 to determine a solution here for these exact values. Okay, I would expect at least one of those on the test. Okay, so here we're going to prove an identity using, if you recognize this, this is sine alpha minus beta. So let's expand that. So this is sine alpha cos beta minus cos alpha sine beta. Okay, that comes from that. Does that equal sine of x? Well, we can simplify, because you know what sine of pi is. Sine of pi is 0. Okay, now I don't know what cos of x is, but I do know that cos of pi is negative 1. And then I have sine x. Are these equivalent? Well, this cancels, and I'm left with just sine of x equals sine of x. Okay, so the left-hand side equals the right-hand side. All right, Now, this next question, 100% guarantee this shows up on a test. This is like one of the most common questions you're ever going to see. Okay, let's see what it says. Let's talk about angle alpha first. It says angle alpha is in standard position with its terminal arm in quadrant 3. So that would be here. And it tells you that cosine of alpha, okay, I'm just going to make that a little bit nicer. So cosine of alpha is -3/5. Okay, looking at that, I can tell this is 4 right away using Pythagoras. Okay, and so in this alpha, this is alpha, cos of alpha is -3/5, and sine of alpha would be -4/5. Okay, let's look at the second angle. It's beta. Okay, beta is in standard position in quadrant 2. And it says sine is 1/3. So using Pythagoras, this is going to give me √8 for cosine, and it will be negative. So I know that sine of beta is 1/3, and cos of beta is -√8/3. Okay, so I've just figured that out by the information that was given. And now it says, what is sine of alpha plus beta? All right, well, we know this formula. Look on our formula sheet. You would say sine alpha cos beta plus cos alpha sine beta. And each of these has a value that is given to us. All right, sine of alpha, that's right here. It's -4/5. Cos of beta, that's right here. -√8/3. Cos of alpha, that was given to us, -3/5. And sine of beta is 1/3. So I can do this, 4√8 minus 3/15. Okay, by the way, what if we did cosine alpha plus beta? Well, that formula is cos alpha cos beta minus sine alpha sine beta. So we do it the same way. We have these values. We know cos of alpha is -3/5. We know cos of beta is -8/3. We know sine of alpha is -4/5, and sine of beta is 1/3. So this is 3√8 plus 4/15. Now, quick question for you. This is kind of a trick question. I haven't seen this asked in a while, but which quadrant is alpha plus beta in? Right, because alpha plus beta is saying if we add up angle alpha, which is here, and we add it to angle beta, however big that is, where is it going to end up? Is it going to be a quadrant 1, 2, 3, or 4? What do you think? And how can you tell? Well, if you look, this angle is positive, and this value is positive. So which quadrant is sine? Well, let's go alpha plus beta. If sine alpha plus beta and cos alpha plus beta are positive, so they're both positive, where does that happen? Then alpha plus beta is in quadrant 1. Okay, so that's a little trick question at the end there for you to think about a little bit. Okay, example 5, we're supposed to solve the equation. So we're going way back to the first 17 examples. We're supposed to find out what x is. And if you remember, anytime you see something like this, you're saying to yourself, boy, it would be great if I could simplify that to one trig ratio. And this kind of looks familiar. Can you look on your formula sheet? Do you have cos, cos plus sine, sine? That looks like cos alpha plus beta. Sorry, not alpha plus beta, alpha minus beta. So let's write cos, and in this case alpha is 4x and beta is x. So this is cos 3x equals 1. Okay, and how do you do that? Well, where is cosine positive? Here and here. The reference angle for cosine, where is cosine 1? This is in radians, so that's at 0 radians. So what is 3x? It's going to be 0, and we'll go around once, twice, 3 times. Okay, and if we divide by 3, you're going to have 0, 2 pi over 3, 4 pi over 3, and 2 pi. All right. Here is the homework for this lesson. Good luck with that.